Good morning to all data ninjas and welcome to our flight to the land of data warehousing. Fasten your seatbelts while we're preparing to take off. We will fly today over wide landscapes of data and the structured heavens of insights. Through the data warehouse modeling terms and the different architecture options, we'll talk about challenges and what's worth keeping, if it's worth keep all the data or not. And then we'll get to the most interesting thing, why are we building our data warehouse? Thank you for choosing to fly with me today. Skies are clear and possibilities are endless. My name is Maria Zakordaev. I'm from Israel. I'm a Microsoft Data Platform MVP and Data TLV organizer. Data TLV is the annual data people gathering in Israel. It's an amazing summit. And if you fancy to visit our pretty country, maybe not at the rough times, but maybe next year, check us out, datatlv.com. Come over as a speaker or as a delegate. It is really fun. And we'll talk today about data warehousing, as I said. And we'll start with terminology and go over each agenda item that I just mentioned. So first thing that will influence our decision how to build our modern new data warehouse is data structure that we need to onboard right into the data warehouse. Structured data coming from files, structured data coming from relational databases, JSON, semi-structured files, semi-structured data, and non-structured data, which is not like non-structured data, is like the main thing that is coming to the focus recently. And there are so many unconventional data sets that you might need to analyze, like sleeping patterns, eating habits, the data stream coming from smart fridge, like to understand what people are buying and eating and what they're throwing away, like garbage can analysis, or pet movement analysis coming through GPS, right, that is on the dog or cat. And then plant growth data, you might need to analyze plant growth data, and Laffer patterns and frequencies, which makes me think that it's more like the more you understand which data you need to analyze, it's more would affect the decision how your warehouse would look like. And today we will go back and forth thinking about traditional data warehouses and modern data warehouse. And what is the difference? One of the main differences that I will be going back and forth today is that the traditional data warehouse used to be central, monolithic data platform using a single database, right? And the modern data warehouse is centralized or decentralized or somewhere in the middle. It doesn't really matter, depends on the use case, but it will utilize multiple cloud technologies. It will be built of many databases that will together play and help your consumers to get real actionable data, real-time data, and get actionable insights, to be able to have actionable insights. And one of the things that is usually discussed is like normalization and denormalization. We'll have normalized data sets that are really good for keeping the data integrity in place, but then denormalization would help us to speed up the queries. And then you would hear, no more normalization. All new data warehouses are denormalized. That's the new paradigm. But that's not true. In your warehouse, you would probably have both. And the new technologies, virtualization technologies like Data Fabric, will help to build virtual, denormalized data structures on the top of normalized data sets. Or there are some technologies that would build denormalized snapshots of the data over time. So you don't need to choose one or another. You will probably have both. And another words that are just all over is data marts and data cubes. What are we using? And again, they will probably both of them, because data mart is a subset of your data warehouse that it fits specific purpose, specific group of people, or some analysis use case. And then data cube is just a way of exploring and analyzing part of this data mart. It will be maybe some OLAP, or online transfer process technologies, or maybe it will be just flat file, right? But it's just a way of analyzing data from the data mart. Schema on read and schema on write. This is again something that is, schema on read is getting a lot of interest, and we don't need to take care of schema. Like everything is flexible, and just put the data in and somehow read it. Putting the data in the data warehouse and applying the schema on the ingestion, this is what schema on write is a very good thing. While you can have schema on read, and this is really easy way to start exploring new data sets that you're not really familiar with, but if you can enforce the schema right from the beginning, you'll have much less data quality issues, and you will be able to understand what you have in your data warehouse or in your data lake. So maybe as a first stages of data exploration, schema on read is a good concept, but good old style schema on write still has its place, and it's really, really important to make sure you know what you store in your data warehouse. Another terms that are all over around, and ETL and ELT, and here I agree. The times of the ETL have passed, and we would be probably building only ELT pipelines these days. ETL stands for extract, transform, and load. In the old days, like a few years ago, we would take some pipeline, right, the product that is building a pipeline, we would extract the data, apply transformations as a part of it, and there will be probably multiple transformations, and they will be coupled in the same pipeline, will impact one another. And then, we will load the data. We would load the data into data warehouse, and that's it. In the ELT pipelines, we will extract the data from the sources, load it into the data warehouse, and apply the schema. Right here, we will apply the schema, if we can, of course. There are data sets where we can't do that, but mainly we will do some automation and data mapping. We will load it into the database. And then we will have multiple data transformation pipelines, each serving different purpose, each building different data mart, maybe different data cube. And why is it, besides of decoupling the transformation stages, each one of those can actually have a different schedule and can be scaled differently, right? And then the main thing is that we will utilize the data warehouse resources for data transformation. And data warehouse is built to work with the data. It has smart query analyzer and a lot of, it's built to process data in the specific way, in the best way possible. And data pipelines, probably not. And it's usually the data pipeline resources are more limited than the data warehouse. Maybe new pipelines, like cloud pipelines, are much better with scalable, but we still will be coupling all the transformation stages together, and that's not really a good idea. So here is like only ETL from now on. ELT, sorry, ELT. And then streaming or processing, right? Streaming or batch processing. This is another interesting different ways of pipelining and moving the data from source to destination. the difference is that in the streaming, the data will be pushed into the streaming pipeline as it arrives automatically. And it's very nice to have some real-time data. Like if we have our dog wandering somewhere out there, we will see where is it right now, and if it's eating something from the from the garbage, and then we will process that right away. But there is still place for batch processing, which will pull the data on some recurrent basis, the huge amounts of data, and will process it, well, using ELT pipelines. But there is still place for batch processing, maybe not daily as in the old way data warehouses, but we will have it hourly, maybe. I'm not sure if every minute is a good idea for batch processing. Should look into streaming. But still, both of them have place, and there is no, we only do streaming pipelines. Like, we will usually do both. Natural language processing, this term is getting into all areas of data analysis, and it's the way that we would interact with the computer using the human language. And lots of tools that you will be evaluating for a data warehouse should have this ability. This is pretty useful feature. Machine learning is a subset of AI in general, right? It's just a subset that combines math and statistics to learn from data. It can improve and it can help to predict future trends, data quality issues, find anomalies in the data, automate data governance, data tagging and procedures, and in applying security procedures. And then it's really evolving, and it's entering into data warehouse world like with a huge speed. Conversational AI in general, it would combine and machine learning and NLP to provide you users engaging in interactive experience in consuming your data interfaces. Right? And then, wow, this is amazing thing, the data lineage. This is one of the most important features of the modern data warehouse, which will help us to understand each number in which column, where it came from, which tables influenced it, what are the data sources, how it was calculated, what was the formula that it was calculated with. And we'll have different layers of lineage. We can have table lineage, where we would only see which table influences which table, and it is easy, right? This we can infer it from the business. But then there is a column lineage, where each column would have completely, maybe not completely, but different graph in the same table, because the columns that influenced it might come out of the join of multiple tables, and in the lineage graph, they will have totally different tables as a nodes of the lineage graph. And then row lineage. Row lineage is the most difficult, and lots of companies are trying to do that. It's really tough, where you not only would know the metadata that was used to build this column, but also which rows it came from, which rows from the source file the data came from. Data catalog, it's something that is really central to good data warehousing solution. Again, as at the beginning we said that modern data warehouse is not one database. It's not one server, it's like multiple services. And how do you know where is your data sets? You must have data catalog, and not regular data catalog, old style, like manual list of sources and their API path or connection string. It would be augmented, it would be automated, right? It will be driven by metadata. The good data catalog provide you with some kind of lineage, table or column usually. If you want row level lineage, you will need to build it yourself. And it has a lot of collaboration features, like who likes which data set, was it useful, what is the data quality of the data set, when it was last updated, how I connect to it. And it would, this good new data catalog tools would also have AI and ML for interactive data consumption, just as Azure Data Fabric, and there is a Denodo, and there's a lot of other companies that are trying to build virtualization layers, and they have data catalog as a part of it. Data governance. In the modern data warehouse, again, which has its data is like all over different services, if you don't have good data governance, lists, procedures. I don't know if you attended yesterday's talk, Alex's talk on data governance. It was just amazing. And you need to have procedures to make sure you can work with all this dispersed data in the effective way. Because if you don't have data governance, you can end up with completely different data silos, and you have no idea which service is doing what. But again, this data governance in a new world is not dictating something. It helps, it empowers to build good data sets with providing them syntax and metadata structure and data formats that can be merged together, fields that you would use to join the dispersed data sets, standards for data freshness, for data availability. Again, global principles, so you can, through data catalog, through virtualization level, easily join the data sets together and analyze them together. Any questions on the terminology? All right, then we go to the architecture options. Any questions on the virtual attendees? Okay. All right. Data warehousing has gone a long way, right? From once data warehouse was really one monolithic structure, centralized, heavily consistent, structured, uniform. Every data source that you had should have been, somehow fit into the structures. It was fast, right? But optimized for structured data sets. And the schema was enforced, of course. Then came these times of data lakes, and everyone was so obsessed with data lakes. It used to be all the time. We called it staging area. But data lake sounds much better. It's not some staging area. And it was great. You can throw away everything, structured data, non-structured data. It's just repositories for raw data. Low cost, just save everything. And figure out what is there, because there is no schema enforcement. Just read and see what you have. There was no transaction support there, and it was really, really hard to mix read patterns and write patterns. They were interfering one with another. And then came this amazing data lake technologies. This is just a bit of a framework that is an addition to the data lake. But again, you can just throw every data type that you have, but it provides you with transaction log for each data structure, which helps to mix writes and reads, enables BI tools to read from the data, transaction support, as I said, governance layer, permissions. Delta Lake is nice, right? It's like something that can be used for everything. It's like a universal tool, right? But universal tools are fine if you can choose only one. And then, of course, you would choose universal tool. But if you can choose tools for each specific use case, that would be even better. And if you're not limited in the number of tools that you can choose. Centralized data platform architecture, as opposed to decentralized, is a bit weird, because we have this operational data plane where all transaction processing is taking place. And it used to be monolith once, But then came this Paradigm microservices and APIs and polyglot persistence. Wow, you can take each transactional data set and choose database technology that fits it well. It is really driven by domains, and it was decoupled long times ago, like, I don't know, 10, 15 years. And it works really well. And all the data still, in most companies, from the really nice landscape of data management technologies, will be pushed with the pipelines into central analytical data plane, where it should be analyzed. And here, domain consent is disregarded. All the data is one place. There is some team of DBAs, data engineers, that need to figure out how to make sense of all this data. What are the data quality rules, right? And they not really know the data well. It's hard. It's hard to know the data from. Again, we're talking about big companies. Like, it's not like the company with 20 people or 100 people. When we have different domains, a lot of data sources, this is really tough to manage this monolith analytical data plane. 5 years ago, we have started to see this concept of decentralized analytical data plane. A lot of different ideas. One of is called data mesh. I really like this approach, architectural approach, where domain data teams would not only manage their transactional data, but they will also manage the analytical data. They know it well. The consumers probably coming from the same team. And then it makes sense that the same people would also build data lakes or data warehouse in the scope of their domain. There can be consumption data products that are merging data from different domains, but the main thing remains, the main data sets remain in the domains. This requires mind shift from pushing and ingesting. Like, when we think about data warehouse, we think about pushing data, ingesting data in some central place, to serving it, to building it in the way that it can be consumed. This is totally different mindset of data organization. Virtual layers like Data Fabric, virtual products help if you decide to go into decentralized way of architecturing your data sets. And again, you don't have to choose, like, I want centralized or non-centralized. Probably in the warehouse of your dreams, you will be somewhere in the middle. Some data sets will be centralized, some data sets will be served by domain teams. And virtualization level can make sense out of it because it has central data consumption point. It knows how to connect to data sets through APIs, prepare data, merge data, build denormalized data sets for your consumption, and it will have data catalog, right? It is the main thing of the Data Fabric tools. And it's much cheaper if you don't need to move the data to duplicate the data from one place to another. This is like how data mesh would be. Okay, I have this zoomed in. In Azure, you will have different teams. Each will have product that they think suits best for their analytical needs. Again, not for pushing data in, but how we make sense of the data, how we want to analyze it. And then they will choose technology for data lake. Again, data lake shouldn't be shared. It's just a tool to getting there, to getting to real fast analysis, right, of the data. Then there is a question that comes in mind. Is there a way to best model the data? How we choose the data structure? Star schema, Snowflake schema, Galaxy schema have been there a long time. It's normalized, it's nice, it's fast for data analysis. But we're not limited to it. There is structures that are best for transaction processing, right? There is a relational schema, object-oriented schema, different flavors of the same thing. But then there is a document database. key value or document. And then you would think it's for transactional processing, but sometimes, again, if you're forced to use one database product, and if you want to build inverted index to process the text files, you can use a document database for that, where you have every key from your documents as a key and the link to the appropriate data location in the document. Then suddenly key value might become tool for doing something right. And there is this data cube or one big table. It's fast in some cases, not always. If you think about Power BI, they need to take this one table and build distinct list of all dimensions that are out there. And the table is huge. That will not be happening fast. But in some query types, in some use cases, it's really great tool. Temporal data models can be sometimes utilized if you want some queries that has a temporal flavor, like as of time, because in each point in time, you might see the different outcomes of your data, like different decisions, depending on when it was valid time, when data was happened, when some fact happened, transaction time when it was logged to the database, and then the decision time. All of them are really critical for some decisions. Data Vault is really nice data model, which is some kind of evolution of star schema. It's built of hubs, which are business entities, and then satellite tables that are historical descriptive data, and then links that combine business keys together, and links can be of different types, and this is like sort of graph, maybe, and the star schema at the same time. It's really, it is normalized. It's not denormalized schema, but it's very flexible, enables rapid onboarding of new data sources, and very well suited for historical tracking. You sometimes will need graph or hypergraph, which is, a graph is made of nodes that are entities and edges that connect two nodes, and in a hypergraph, edges can connect multiple nodes together. And then it's really hard to use the same database product to model this. We used to have a lot of tricks to store this data in the SQL Server in the old days. Materialized paths, nested sets. I don't know if anyone used that. It's crazy. It's possible, but it's not optimal. You might just grab a graph database and add it to your data warehousing stack. Okay, we talked about terminology. We talked a little bit about various architecture options. Let's talk about challenges. And traditional data warehouse challenges, we know there's a lot of data types. It's hard to fit everything into the same schema, into the same structure. Data is growing. Scaling one database product is a very heavy thing, providing it's not the cloud technology, right? If it's old-style data warehouse, like SQL Server, Exadata, you just buy the box, and that's it. Adapt to changes in the data structures are really tough. Maintaining data security, data quality, again, if this is like something that is coming from all over the world, different domains, different data structures, centralized team is really struggling to making clean data. And again, we talked about speed and data structure changes, and that's the main challenges. And like we have all those new data cloud data warehouses like Snowflake, like Synapse, and they have solved a lot of challenges, mainly in the performance area with scalability, that they allow us to scale up and down at the times of the consumption peaks. High availability really improved. You can have your data warehouse available to users all over the world. Changes, every new feature, you don't need upgrades, you don't need maintenance windows. This is really cool. And pay-as-you-go thing helps small companies to start building things. And for big companies, we can pre-buy the data warehouse like beforehand and save a lot of money. It's really flexible in the cost of ownership area. But the most challenges are still there. You still need to figure out how to model your data, where to store it, how to maintain data security and data quality, and how to adapt to changes, adapt to new requests and new requirements. So it's not, technology is not solving most of your problems. It's really, you will need to learn new services that are out there, and the cloud is evolving, it's changing every day. There are new features come out, new services, and that would solve most of the data warehouse building problems. What's worth keeping in the warehouse? What is your strategy? And I hear a lot, let's keep everything. We have this data lake, just put everything sometime. We will need it. Someone will need it in the future. And then there is this analogy that I like to think of. If you go to Instagram, there's a lot of pictures of cats, and you can download all of them and run some machine model on the top of them and find some facts, like the colors of the cats that people really like, or the most chosen breeds, and the fact that people are really like cats. Is it really important information? It's not really important. It's not really interesting. I can tell it, without running the machine learning. People like cats. I have 3 of them at home. And your companies probably have a lot of cat pictures, a lot. And maybe the storage is cheap. You can throw in everything, but data organization and insights are not cheap. People who would take this data, spend time to figure out there is nothing interesting in there, it costs money. And if there is no regulation, and that you need to store data for a certain amount of time, and then you should think if there is anything in the old data that I can't understand from the recent data. And in a lot of use cases, it doesn't matter. Like last year or 2 will probably be even better for taking decisions than the data from like last 10 years. Not in all use cases, of course. There are use cases where like 10 years ago, actions really matter. But in a lot of use cases, they're not. You don't have to don't store noise. That's it. This is the noise. And we need to figure out what is noise and what is not. This is tough, but it's possible. All right, and then we're getting to the last part of this presentation. What are we building our data warehouse for? What is its purpose? And it's much more important than choosing the technology. We are all technical people, and we just run, wow, Databricks. Everyone is using Databricks. I must have new data warehouse with Databricks and Power BI. This is it. This will be the warehouses of our product dreams. And then, if you ask yourself, do you know why we need a new warehouse? What is the business objective? Do we have long-term goals, short-term goals? Do we understand them? What are we trying to achieve here? We're trying to improve data quality. Then maybe it's not Databricks that will improve data quality. Maybe we will use some other product. And then are we reducing time to regenerate reports? And yeah, we need to speed things up. Or maybe we need to establish new compliance rules, define marketing strategies. This is much more important to think when you build the new data warehouse. What are our current data capabilities? Are there gaps? Maybe we have Excel and our users are just happy with it. And you can go away with Excel. It's really cheap, has Power Query inside, great visualizations, and it's, you can save a lot of money to your company by just staying there and maybe buying some data quality product that checks for data quality. But then you need to think, all these you need to have evaluation criteria. How do you know that something that you're going to build is better, that is something that's already there? What are gaps? Do we have any new data structures to onboard? What our clients, what do they need? What are their consumption needs? Do they have any new analytical capabilities that are missing? Performance, cost effectiveness, all over the place. Or security. Maybe the current product is not secure. Then maybe we don't need to build a huge, new data warehouse. Maybe we just need to focus on security. And there is always constraints like budgets, data sources, time constraints. People don't like to change the technology they are working with, and they might sabotage the new cool technologies that we will choose for our new warehouse. And then it's really hard to build an amazing data warehouse of the product's dream. If people don't want to develop things and adapt, it's hard to adapt. It's hard to change habits. Okay. As the last couple of minutes, we have, 10 minutes, right? I'd like to think how the future, 15 minutes, okay. How would future data warehouse would look like? Like in 5 years, in 10 years? And it will probably, the technology goes in, improving real-time data processing, streamlining the data right to the business to make faster decisions. And this is something that is really hard to do, just, again, because we tend to move the data around, duplicate it, build it in one place, process and analyze it in third place, and it just takes time. And this is where we want to head into, to real-time data processing. Data warehouse should be autonomous. What does it mean? I no longer want to spend my time learning one database product, how to trick it to work faster, to learn the optimizer, its very small nuances. I just want it to be self-tuned. I want it to be self-optimized. I need to really understand the purpose. I need to understand what I'm trying to analyze. What is my data structure? And then I need to find product that will do it for me. And it will be self-managed, self-secure. I would not need to think about it, okay? And especially not tricking relational database to serve the graph model, right? Or taking some key value store and trying to serve the analytical data. Or having like data lake, which is great tool. Again, data lake is amazing tool, is generic. And then I need to figure out how to make it work. It's not self-driven. I need to work hard and bring more technologies to make it work. I want something that when I define the purpose, when I know what I'm going to do, like ChatGPT, if you define your question really well, you give it all the details, the result is usually really nice. It's just, wow, this is what I need. I want the data warehouse to do the same in the future. And multi-cloud is nice strategy. There is no vendor lock-in. You can choose optimal costs, and when it's more accessible, then cloud providers would also start, to adjusting costs one to another. And if I want to use multi-cloud architecture, then virtualization is a key to success. Unified access to all disparate data sets across the data technologies, data services, across clouds that allow, through federated data access to work effectively. Quantum computing is a great, promising technology. However it would work, it will probably dramatically reduce data processing times. And it's probably coming in the next 5, maybe more years, I don't know. And AI technologies continue to evolve and mature, and their integration into data warehouses will likely become standard. It's almost standard now, but it will be definitely the standard way of working with the data. Conversational AI interfaces, that NLP, identifying anomalies, predicting future trends. This is the must in the modern data warehouse and, of course, in the future. Automated data governance, automated security, that will be a key to success. I asked ChatGPT yesterday to draw the visualization data warehouse landscape. And this picture is really captivating. This is just so amazing with all those colors, and I really like it. And the landscape of data warehousing is evolving at very fast pace. Okay? It is driven by demand for real-time actionable insights. We need to follow the changes, follow the new services that are born every day, new features. And it means we need to continue to learn, adapt, and innovate. Thank you for listening.